Hey, I'm Chris Ralph, the professional prospector, and today I'm going to talk about some questions that I get. People comment on my videos and ask me various questions, and I get questions like, where does gold really come from? You know, how does it get to where it's at? And I get also questions like, is gold made out of stardust? Maybe. And what is gold? You mean, what is it? So, you know, gold's gone up a lot in value in recent times due to war and other inflationary concerns. And I thought it might be a good time to take a look at some of these things. We're going to start off with what is gold. And hey, gold is an element. On Earth, everything is made of a certain number of chemical elements. They're basically atoms of unique material, and so let's take a look at that.
So here's a table of elements. It just has the abbreviation names, the chemical names for all these different elements. Everything we know and see in the world is made up of this group of materials. You just combine them and put them together and you make everything. Here I've circled gold on the table of the elements. Its chemical symbol is Au, which is for the Latin word for gold, which is aurum. This is the atomic model for gold. Now, this is not what an atom of gold actually looks like. This is just a model that kind of shows the conceptual arrangement. There's 79 protons, 79 electrons, and 118 neutrons. The number of neutrons is just what it takes to make the whole thing stable. So 79 protons, 79 electrons, its atomic number is 79. And basically the electrons swirl around the nucleus, which is the protons and the neutrons, although not in perfect circles like this. It just kind of zooms in and out. And this is what gold is made of. It's made of protons, neutrons, and electrons. There's not some other material that gold is made from. It's an element, one of the basic elements of the universe. I think some people think of gold like some sort of an alloy or something where you mix certain metals together and make something else. Here you can see brass, which is pretty close to gold. Brass is a combination of copper and zinc. And then there's bronze, which is a combination of copper and tin. And of course, by mixing different ratios of the different metals, you can make bronzes that look much more gold colored, and you can make brasses that vary in color as well, depending on what you're actually mixing together in the alloy. But gold is not an alloy, it's an element. It is what it is. Gold is made of gold. But some might ask, well, if gold is made of protons, neutrons, and electrons, well, how did they come together to become gold? How did somebody or something or some process assemble the protons, neutrons, and electrons to make gold? Well, this is a process that happens in stars. And in fact, stars take the simplest of all the elements I showed you, which is hydrogen, which is just one proton and one electron and 0 neutrons. It takes that and puts them together and puts several of them together, and through a process of nuclear fusion makes helium. And helium is the second largest element. And for the most of a star's life, it spends its bulk of its time burning through hydrogen and making helium. But when it gets toward the end of its life, it starts making other elements. It starts burning up hydrogen and helium together to make lithium, or puts other things together to make other different elements. And in fact, in a normal sun like our sun, eventually as the sun reaches its last phases, which our sun is still a long ways from there, but eventually it would reach that phase. When it reaches the last phase, it can make elements up to, on that periodic chart, the element of iron. But any elements heavier than iron that have more protons and neutrons require a supermassive star that's of extra size And these stars, even during their lifetime, and they actually burn out much quicker than our sun. A supermassive sun like I pictured here will burn out really quickly in a tiny fraction of the time that our sun takes to burn through. And then it explodes. An exploding star like this is called a supernova. And when a star explodes, a huge star explodes like this, it releases more energy in a few seconds than it did in its entire life up to this point. Just a tremendous amount of energy is released. And actually, when these things happen, they can be bright in the sky of Earth, even though they're incredible distances away. We can even see individual stars when they explode in other galaxies. So it's a huge amount of energy that's released, and it's thought that during this process, when there's so many neutrons and protons and everything flying about, that it's this process that creates all the elements larger than iron, with nucleus and more protons and more protons and electrons than iron, including gold, are produced in this kind of a process. When the star explodes, it leaves a giant dust cloud called a nebula that is the remains, the dust that's shot out from the exploding star. And these things can be huge. I mean, obviously they're much larger than a star or even a solar system like our own. The dust spreads out because of the hugeness of the explosion, spreads out for considerable distances. Eventually, as the force of the explosion outward diminishes, you find that clots of material start to collect and spin and start to just collect into solar systems or suns by the force of gravity. Eventually the dust starts to collect, and bits and pieces of rock come together by gravity, and you start getting planets form, or at least planetoids, the beginning of planets. You can see by the darker rings, these are areas where the nearby planetoids have swept away the dust or collected up the dust that's in its ring of orbit. Now, about gold in this kind of a setup, I want to mention that there's not like gold nuggets floating around in space or something like that. This is a dust that's a mixture of all kinds of sorts of elements. There is gold here, but it's in tiny, tiny, tiny fractions. And the system continues to grow, and the planetoids collect more and more dust, and bits and pieces of planetoid rocks collide with the main bodies as they continue to grow in size. And during this time, this is what the Earth looks like. It's called the Hadian Period by geologists, named after the Greek word Hades, which in Greek means hell, because it's a hellish kind of a place with molten lava and hardly any solid material on the surface. It's just too hot for anything. There's no water because its surface is too hot for liquid water. And this is a close-up of what early Earth probably looked like during that Hadian time period. Constant bombardment with meteorites, lightning strikes, a surface that's only just solid enough to not be molten. It really was a hellish place to be. Luckily, there was no life at this time. And Earth, it was just a mixture of all kinds of different elements. And like I say, the gold was present here just as tiny, tiny traces. There was no concentrations of gold. There were no nuggets. It's just that the rocks had a few parts per billion in them, and that's where the gold was. Eventually you reach a point where the Earth is cooled enough that you can have liquid water on the surface. Yes, there's still volcanoes all over the place, and it's still pretty hot. That big thing in the sky in the back is actually the moon. The moon has been receding away from us for millions of years, and if you run the clock backwards for hundreds of millions of years, the moon gets a lot closer and a lot bigger in the sky. Now, to the right-hand side, you see some water and some kind of blobby stuff in the water. Believe it or not, that's life. Now, it's not some kind of matty, furry creatures crawling around in the water. Those are really more like blobs of algae mats. It's a very simple type of life. There's a few forms that are more than one-celled, but not much. The life that exists is very simple. And that's just how it was. And still, you start to see, though, when you have liquid water at the surface and the earth is cooled some, we see the earliest beginning stages of concentration of gold, from traces and traces in the rock into more economic and valuable deposits. You see, it's superheated waters like this. This is a boiling pot in Yellowstone, but like this is what's necessary to dissolve the gold out of the rock and concentrate it into valuable and worthwhile deposits. So I want to talk about some of the different types of gold deposits that form, at least how they form originally in the earth as a hard rock deposit in place in the rock. Now, this little diagram lists several different types, several major types. There's a volcanogenic massive sulfide, which forms on the bottom of the seafloor. There's epithermal types deposits, which those form actually fairly close to the surface. They can be from, near surface to perhaps a mile down. Further down, you might have the porphyry and Carlin type deposits that form several miles, perhaps 5 miles or even more down. And then the deepest of all, and one of the most prolific, is the orogenic, which orogenic means it's related to mountain building. These deposits form deep at 5, 10, sometimes even 15 miles below the surface, and are only exposed by mountain building uplift that brings them up to the surface, where they can be seen and exposed by weathering. This is a hot spring with pools of very hot water at the surface in California. It exists along a fault line where the hot waters rise to the surface along the fault, and probably down below some, few hundred yards to a half a mile, maybe more, there's a gold and silver deposit that's forming, an epithermal type deposit. But it's this hot water, whether it be volcanogenic, porphyry, Carlin, even orogenic or epithermal, all of these types of deposits involve hot water that leaches gold from the surrounding rocks. It literally dissolves the gold and then redeposits it in a concentrated form to make a quartz vein or something else that would be worth processing. Now, I mentioned toward the beginning of this video that the rocks that just come along on the surface, the volcanic rocks and other rocks that form, they just have tiny traces of gold in them. Literally, an average rock on the surface of the earth has something like 1 part in 250 million of gold. So if you had 250 million pounds, basically a mountain of rock, if you could somehow extract all the gold from it, it would have a pound of gold out of the 250 million pounds. This is, though, what can be done when the hot waters leach that gold out of the country rock and then redeposit it. Now, gold leaches out, but it just so happens that quartz is also leached by the same hot waters and often gets redeposited in veins along with the gold and some other minerals. And you end up perhaps with some super rich quartz like this. Now, here's another example of some beautiful gold with quartz. This is a beautiful specimen of a really spectacular grade, but this is what happens when you leach the traces, the tiny part per billion traces out of a whole bunch of country rock. Literally, perhaps more than 1 million pounds of rock were leached to be reconcentrated as a beautiful gold specimen like this. But this kind of stuff was mined in the 1800s, and there's not that much of it still being mined. Some places, maybe more remote around the world, and But for the most part, most gold today is mined in huge open pits. When the gold isn't concentrated down as much, well, then you can end up with a low-grade deposit where there's still a good economic amount of gold in a huge area of rock. And this is what's mined in most places and how most gold is produced in our modern times. This is a huge pit in Nevada, and you can see that they've mined huge amounts of rock, and this goes to be extracted to take the gold and silver out of it. There are actually many really huge gold mines in Nevada, and of course around the world, and in Nevada too, there are underground mines as well. There are even some when you have a huge pit like this that the gold continues into the earth, into the rock below the level of where they can economically make a pit like this. They'll continue mining the ore underground, and so there's several pits like this in Nevada where they've dug a giant pit, and then at the bottom they put in underground workings and continue working the deposit from underground. And it's those gigantic operations that produce the really huge amounts of gold. But hey, they have to, because, well, it's a big operation with huge amounts of equipment and hundreds of employees and lots of people working, so you need to be producing a lot of gold in order to meet the bills and be profitable. But there are also a lot of smaller operations, and in fact around the world, individual operators, some operating on a pretty small scale, produce in total about a third of all the gold that's mined, and the big mines only produce around 2/3. Now, the bulk of the artisanal miners, I mean the small-scale operators, are actually in developing countries where the people work for a few dollars a day, but that's honestly the best option they have for making a living. This is me working in the Nevada desert with my dry washer, shoveling material in, because, hey, I enjoy finding gold for myself. And in fact, it's an interesting hobby practiced by thousands of people. Hunting for gold is an interesting outdoor activity that can be applied by many families, sons and dads and fathers and daughters and wives, and everybody can get involved because you get to commit to your level of involvement and make your own choices for yourself. But it's fun, and there's always the chance that you could find something really great. And these days, with the price of gold being so high, even finding a small nugget like I did here, it's an exciting thing and well worthwhile. Now, learning to find gold is a skill in and of itself. It's not just like you're going to randomly walk out there and just pick up big nuggets lying all over the ground. It's a skill you have to learn. And it's a skill you might want to learn for yourself, because I certainly have enjoyed it for all the years I've been doing it.
Now, you saw some of the things about panning for gold and that kind of stuff, metal detecting, and I do a lot of videos on that, and you might want to stay tuned to my channel. But I wrote a book about prospecting for gold that really tells you what you need to know to increase your skills and go out and find gold. It's called Fistful of Gold, because that's what I'm hoping you'll be able to find, is Fistful of Gold for yourself. And I'm going to tell you a little bit more about my book right now. So let me tell you a little bit more about my book. It's called Fistful of Gold, and I wrote it because I want you to be able to go out and find for yourself Fistful of Gold. And you can see that it's an encyclopedia with all kinds of information, pictures, and that sort of thing. It's not in color, but color would have cost me a lot more to have printed, and so the book would have cost a lot more. It's for sale on Amazon, and you can pick it up. I'll put a link in the description below. I also serve as the editor for a prospecting magazine. It's ICMJ's Prospecting and Mining Journal. And honestly, you should check that out. We got stories and information, legal stuff, everything you know to increase your skills as a prospector. I write articles in this every month, and a lot of other very experienced prospectors contribute to the magazine as well. So check the magazine out. Also, I have a website, and the website is at NevadaOutbackGems.com. I'll put a link for it in the description below. But there's gobs of information there that you will find useful in your prospecting efforts. Finally, I want to say that I really appreciate your comments and thoughts and even positive criticism. Don't come on there and just toss out insults, because I'll just delete your comments. But if you've got helpful things to say and questions to ask, do write and put those in the comments, because I answer my comments to people, and you'll hear from me in responding to you. So if you've enjoyed this video and you like what you see and you're interested in finding out more, well then sign up, subscribe, and hit the notification bell so they'll let you know when I post new videos. And like it and share it if again you see stuff that you really are excited about. And I'll be coming out with lots more new videos, and so we'll see you again real soon.